Okay. All right. So in this last part of the series circuit, we want to think about the resistance in a series circuit. Okay, and there's no way in the simulation to directly measure the resistance, so we're going to have to do a little bit of thinking back to what we just did before, okay? But we want to know, how does adding more resistors in series affect the overall resistance in the circuit, right? Basically, we're trying to see, does it make it harder to go through the circuit? Is it now easier to get through the circuit, or is it the same as it was before? Okay, so again, you're going to put your data into the next slide. So let's go back to the simulation. Okay, so again, if you notice, we can't measure, there's nowhere that we have that we can actually measure the resistance, okay? So the only way that we're going to be able to do that is sort of by thinking about the current, okay? So if you remember before, when we did Ohm's law, okay, right, we learned something about the current and the resistance. Remember what that was, I hope? Okay. So remember we made those graphs and we came up with this equation, I equals V over R, which is Ohm's law. Okay. You saw it this way when you increased the resistance in the circuit, okay, the current decreased, right? When the resistance goes up, the current goes down, right? So we can use the current as an indicator of what's happening to the resistance, because we can't measure the resistance directly in this simulation, okay? So we have to kind of use the current as an indicator. So really what we want to measure is the current, and they want to infer what happens to the resistance, okay? So in the series circuit, okay, when you add more resistors, what happens to the current? That's what we're really looking at. Okay, so let's look back at the simulation real quick. Okay, so again, we want to do this. We want to think about using these ammeters. Okay, you can put them in various places in the circuit. Okay, and as I add more resistors, I want to look and see what is happening to the current in the circuit. Okay, the more resistors that I add, what's happening to the current in the circuit. Okay, so again, this is where you're going to get your evidence. Screenshots, you might get data table, you might get something like that, all right? But somewhere in your evidence, it's going to have to talk about Ohm's law, all right? So we're going to see what happens to the current and then infer what happens to resistance, because we know those are inversely related. Okay, so less current means there's a higher resistance. It's harder to get through the circuit. Okay, and you're going to put your evidence there.